Okay, in the next part, which binary number is added as a remedy in BCD if any impossible value has been produced? Like if you got any number that is greater than 9, so as the compensation, what you will do, you will add number 6. Okay, you will add number 6. Okay, the binary integer, next question is the binary integer represent a character from computer's character set. Define the term character set. Now, what is a character set? Basically, the system of representing languages in, so it can be text, it can be number, it can be data, it can be symbol, it can be any emoji. So when you are representing different languages using different, characters, that is basically your character set. So technically, how can we define it? That it is a list of characters that have been defined by computer hardware and software, and it is necessary to have method of coding so that the computer can understand human characters, right? Now explain the difference between ASCII and Unicode character. First of all, you should know what is ASCII stand for. It stands for American Standard Code for Information Interchange, and whereas Unicode is Universal Code. Okay, so the difference is that ASCII, let me write over here, ASCII is basically 7-bit. Okay, and they're not talking about extended. Okay, remember, so extended is 8-bit, so we're just talking about ASCII 7-bit code. Okay, and it can have 128 different characters. 2 raised to power 7 is different to 128 characters. Then all English letters, numbers can be represented using ASCII. Okay, and also it is easy to read, write, and understand. Okay, so whereas your Unicode is universal code, it could be 16 or 24 or 32-bit character. Okay, and it can represent different characters between the range of 65536 to 4294. Okay, this all depends upon the system that you are using. Okay, so it also contains all major languages other than English also. Okay, English also, but other than English, it contains all the major languages of the world and different symbols and emojis also, right? So this was the basic difference. Okay. Okay, the next question is that the ASCII code for A is 41 in hexadecimal. Calculate the ASCII code in hexadecimal for Z. Okay, the ASCII code for A is 41 in hexadecimal. Okay, so what you have to do, this question is a little bit tricky. The 41 value is given in hexadecimal and you need to figure out the value for Z, right? So what you have to do, first you need to convert this 41 into its equivalent decimal, right? So how you will convert into decimal? So you have to multiply it with 16, 4 into 16 plus 1 into 16, and then you have to give them power 0 and then 1. Okay, and 16 for the 64 plus 16 raised to power 0 is 1, so 64 plus 1 is equals to 65. Okay, so we sorted out that the hexadecimal value for A was 41. Now in decimal it is 65. Okay, so they're asking you to calculate the value for Z. So how many digits we have in English from A till Z? We have in total 26 letters from A till Z. Okay, and the first letter is being calculated, its value 65. Rest how many are left? 25. Okay, so according to our knowledge, if I add 65 with 25 because the first letter I know the answer is 65, so I've been left with 25 letter. So 5 plus 5 is 10, 6, 7, 8, 9. So the decimal value for Z is equals to 90, right? This is the decimal value. But what I have to do? I have to find out the hexadecimal value, not the decimal value. So first I found out the decimal value that is equivalent to 90. So now what I can do, I can apply my knowledge of converting the decimal number into hexadecimal number. So how do we convert the decimal number into hexa? Simply by dividing it with 16. So I will divide it with 16. So 16 5s are, and I get 16 5s are 80, and remainder I get 10. So I can represent in hexadecimal 5, and 10 equivalent is A. So for Z in hexadecimal is equivalent to 5A. So we can also check it in the book. In book C, character A, which was given the value of 41 over here, its equivalent was 65. Okay, and I added 25 more and I got 90, and when I converted this 90, the decimal value into hexa, I got 5A. Okay, so both are same.